Okay, so we left off on Wednesday. We were talking about converting measurements and putting them in feet, inches, and eighths. A lot of times for construction, guys, stick with me. For construction, we only measure to the nearest eighth. When we're working with wood, the expansion and contraction in the material can be enough that, guys, answer yourselves. The expansion and contraction in the material can be enough that an eighth of an inch is really all the precision that we can hope for anyway. So we left off on Wednesday dealing with some of those conversions. And we're going to start off today dealing with if we start in decimal feet. So in decimal feet, and again, I want to get to feet, inches, and sixteenths. So one of the problems on that worksheet we had, number 3, was 5.73 feet. To convert that to feet, inches, and sixteenths, I take off the 5. So I have 5 feet. I'm going to take that 0.73 and I have to convert that now into inches. To do that, I know that 1 foot is 12 inches, so we're multiplying by 12. So 0.73 times 12 is 8.76 inches. Off of there, I need the 8 inches. And then I take my 0.76 and I have to convert it into eighths. So I put it over 1. Right now that's a denominator of 1. To make it 8, I'm going to multiply by 8 on numerator and denominator. So that's going to be 8 here, 1 times 8. My 0.76 times 8 is 6.08. So that's between 6 and 7. It is closer to the 6. So that's 6/8, which reduces to 3/4. So that measurement, gentlemen, that 5.73 feet is 5 foot 8 3/4 of an inch. So if we keep going, number 5 on our worksheet was 19.31 feet. So once again, I'm going to pull off the 19. That's my whole feet. I'm going to take my 0.31 and I have to convert that into inches. 12 inches in 1 foot. So I do 0.31 times 12. Gives us 3.72. That's now in inches. So I take the 3 whole inches off of there. And now I take the 0.72, converting it into eighths. So I subtract off the 3 here. And I multiply that 0.72 times 8. Gives me 5.76. Now that's between 5 and 6. Which one is it closer to, 5/8 or 6/8? Definitely closer to the 6/8. And of course, again, that'll reduce to 3/4. So 19 foot, 3 3/4 of an inch. I'm going to jump up to number 11 here. 5.208 feet. And again, putting it in feet, inches, and eighths. I've got my 5 whole feet. I'm going to take that 0.208 feet and change it into inches. 1 foot is 12 inches. So the feet cancel. I got 0.208 times 12 gives me 2.496. Now again, I take the whole number off there. This time that's the whole inches. And it's that 0.496 over 1, and we're going to multiply by 8 on top and bottom. So 0.496, I'm going to subtract off the 2 here. So I take my 0.496 times 8 is 3.968. That's between 3/8 and 4/8. Which one's it closer to? Definitely closer to 4/8, which is going to reduce to 1/2 inch. So that's 5 foot 2.5 inches. Okay. Well, let's look at what if we start out with inches and I want to get to feet, inches, and sixteenths. So number 4 on here is 89.32 inches. And I want to get to feet, inches, and sixteenths. So I have to start out converting that into feet. So I take that 89.32 and I divide it by 12 to get 7.443333. So that's telling us we have 7 whole feet. Questions? No? Okay. Shall we set it aside for later? Just in case? I'll set it aside till class tonight and see what you feel.
I've got a tutor at 2:30.
Okay. Okay, I'll talk to you in class. So we've got 7 whole feet. So I'm going to take this here, I'm going to subtract off the 7. And now I have to convert that back into inches. So we're going to multiply by 12 to make it back into inches. So I've got 5.32. We take the 5 off of that, that's our whole inches. Subtract off the 5. Now I got 0.32 inches and I'm converting that to eighths, so times 8. That's 2.56 Again, that's between 2/8 and 3/8. Which one's it closer to? It's closer to the 3. Perfect. So that is 7 feet, 5 3/8 inches. Let's do number 6. We have 214.97 inches. Again, going to the nearest eighth. So 214.97. Now, what's our first step? Yeah, we convert it to feet by dividing by 12. So we got 17.91. So we're going to take the 17. That's our complete feet. So take off the 17. We have that 0.914166666. What are we going to do with that? Multiply that by 12 to turn it back into inches. 10.97 inches. So I'm going to take the 10 whole inches off of that. So subtract by 10. What do we do to the 0.97? We're turning that into 8, so we multiply by 8. 7.76. So that's saying that 7.76 that is between 7/8 and 8/8. Which one's it closer to? Actually closer to 8, which is 1 whole inch. So what that means here is that this is not going to be 10 inches, it's going to be 11 inches. So that's 17 feet and 11 inches to the nearest eighth of an inch. Okay, well, enough of those. That is a skill that's really important to have. Where you would use it, like I said, if we're squaring up a foundation, when you set up these, you set up your batter boards. Have you guys done squaring up foundations at all yet? No, just building on top of existing foundations? Okay. What you do is, let's just say that this black outline is where I think the building is going to go. So what you do is you actually put stakes in the ground and you put, they're called batter boards, on each corner. And what that does is that gives you room to move strings around. So let's say I think I'm going to want this corner right here. So I'll put a nail in the board there, and I'm going to run a string across. Put a nail in the board here to where I think that's going to be. And a lot of times I'll start on a side if there's another building that I need to line up with, or whatever, I'll start on a side that has to line up with something else. Maybe it's lining up with another building, maybe it's lining up with a street or whatever. So that string gets lined up with whatever it is I'm trying to line it up to. And then I'll put a string in here, I put a nail in here, and run a string this way. And now I have to double check to see if that's square. So what I will do is, let's say this building is going to be 40 feet by 28 feet. I'm going to measure from here down this string 40 feet, and I'm going to make a mark on that string, whether I do it with a marker or whether I hang a little piece on it or something so that I have that marked. Then I'm going to come over here and I'm going to measure out 28 feet, and I'm going to mark that string. Then I'm going to measure across here. Well, to measure across, I need to know what I expect that length to be. Well, we find that by using our a squared plus b squared equals c squared. So it's going to be the square root of 28 squared plus 48 squared. So square root 28 squared plus, I don't know where I got the 48 from, that should be 40 squared. 28 squared plus 40 squared is 48.8262. Now I can leave this right in the calculator. That tells me this has to be 48 feet. I'm going to subtract the 48 off. Just as that, but now I'm going to turn that into inches by doing what? Multiply by 12. So it gives me 9.91, so that's 9 inches. I subtract off that 9 inches, and then what? If I'm going to the nearest eighth inch, I'm going to multiply by 8. So I get 7.3. That's between 7 and 8. It's closer to 7/8. So that tells me that measurement across there, I want it to be 48 feet, 9 7/8 inches. If it's not, I can move this string here up and down the board. If it's too short, if I need it longer, I move the string over this way to make it longer, or whatever I need to do to get that to 48 feet, 9 7/8 inches. So I do the same thing. I'm going to measure from here. I'm going to measure across to here. So I can put a string on, run a string there, and do the same here. Once I have that done, then we just measure diagonally. We'll measure this way as well to make sure we get the exact same measurement that way, hopefully 48 feet, 9 7/8. If not, we adjust our strings a little bit. We come back and adjust, make sure these are 28 feet and 40 feet respectively, so that we don't mess that up as we're messing around getting things squared up. Now the other side of that is, what if we have a measurement that's given as 27 feet 4 3/8 inches, and I need to do some calculating with it. To calculate with that, I need to turn it into decimal feet. So to make that happen, we're going to do the exact opposite. We're going to reverse the steps that we just did. So we're going to start out with the fraction 3/8. So I'm going to start out with the number 3. I'm going to divide it by 8 to turn it into decimal inches. So that 3/8 of an inch is 0.375 inches. And now I'm going to add on my 4 inches. So it's now 4.375 inches. So now I'm going to take my inches and turn it into feet by dividing by 12. So we get 0.364583, and then we add our 27 feet to that. So depending on how many decimal places we want to go, I'm going to go 27.3646 feet. So then that is now a form that we can use in the calculator for calculating other things. If you were to go on to the second semester of this course, I know we're in the second semester of the course right now, but there's actually a second course that follows this one, where we do a lot with similar figures and finding missing parts of triangles. We deal a lot with finding the chord length of trusses or rafter lengths and stuff. We do a lot of calculations where we take a measurement that's in feet, inches, and eighths, or feet, inches, and sixteenths, and we have to convert it into a decimal measurement so we can use it. Okay, well, moving on then, that's enough of our stuff from last Wednesday. Let's take a peek now at dealing with the algebra and getting into the stuff we need to do to finish off our graphing side of all this. We looked at, before spring break, we looked at that slope formula. What that slope formula was is it dealt with, you have 2 points on the graph. Let's say I'm going to give you the points negative 3, 5. So it's right there, negative 3, 5. And, let's do 3, negative 3. So that gives us a point right there, 3, negative 3. And we want to find the slope of the line that goes through them. Now, if you recall, we're looking at, we have our rise, in this case it's a drop, and our run, we form that right triangle, that ramp. We found the rise from here to here is just the difference in the y coordinates. So we did y2, oops, we'll do that right. The rise was y2 minus y1. In this problem, that would be the negative 3 minus the 5. The run, this distance across here, is the difference in the x coordinates. So for this problem, that would be 3 minus a negative 3. So x2 minus x1, which will become 3 minus a negative 3. So looking at this, we have negative 3 minus 5, which is negative 8. 3 minus a negative 3, which is positive 6, which gives us a slope of negative 4/3. So that was our slope formula. Now, there are some other things that we'd like to be able to find from this. One of them is the distance. The distance between those points. So if I want to know the distance from point A to point B, well, we look at what I've drawn here for slope, and it's a right triangle. We know that this side of the triangle, this leg of the triangle, is the rise from our slope. This leg is the run. So we have, for right triangles, we know that a squared plus b squared equals c squared. C is the distance, that straight line distance from A to B. Well, A is our run, or our rise, I should say. B is our run. So it's the rise squared plus the run squared, or the other way around. We could have done the run squared plus the rise squared. And then, of course, we square root it to get the distance. So what that ends up being, if we go up here and we take these pieces out of the formula and put them in there, is the distance between those points becomes the square root of, the run is going to be x2 minus x1 squared. The rise is going to be y2 minus y1 squared. So remember our points, I'm going to bring them down here so I have them. Negative 3, 5, and 3, negative 3. So the distance between those 2 points, x2 is going to be what number? That's going to be the x coordinate of the second point, which is 3, good. minus, what's x1 going to be? Careful. Negative 3, there we go. That's going to be squared. Plus, y2 is going to be negative 3 minus y1 is 5. Of course, that'll be squared. So now, of course, we got to work through this formula. What is 3 minus negative 3? 6, good. That's going to be 6 squared. What is negative 3 minus 5? Negative 8, so it's negative 8 squared. So now I can punch that in the calculator. Second square root, 6 squared plus, I got to put it in parentheses, negative 8, close the parentheses, squared. Now, in most of your calculators, you'll have to do this. When you square a negative, you're going to have to put it in parentheses like that. And it comes out to be 10 units. So the distance between those points is 10. Now, if you do it carefully, you can actually put this in your calculator. Second square root, parentheses, 3 minus negative 3. Notice I don't need the extra parentheses around the negative 3 there. Squared. Plus, parentheses, negative 3 minus 5, close parentheses, and squared. That should work out, and there it does. It gives us our 10. So if I give you 2 points, let's say 211, and I want to know the distance between 211 and negative 3, negative 1. We would apply this distance formula, which is what it's called, to find that distance, or the length of that line that connects those 2 points. So I'm going to label this point 1 and point 2. Remember that distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And let's plug in those points. What goes in for x2? Point 2, the x-coordinate is negative 3. Minus, what goes in for x1? 2. Point 1, the x-coordinate is 2. That's going to be squared. Plus, what goes in for y2? Negative 1. Minus, and then y1 is going to be the 11. You're correct. That'll be squared. So now we've got to combine. Like I said, I could punch this in the calculator like this, but this one I'm actually going to work through by hand. What is negative 3 minus 2? Negative 5. Good. That's going to be squared. Negative 1 minus 11. Careful. Negative 1 minus 11. Negative 12. There we go. That's going to be squared. So now we've got negative 5 squared is going to be, it's going to be 25. Remember, negative times a negative is always a positive. So negative 5 times negative 5 is a positive 25. Plus, what's negative 12 squared? 144. Perfect. So now we add those together. 25 and 144 makes 169. The square root of 169 is 13. So those 2 points are 13 units apart. Now I did that one by hand because I knew it was going to come out to be a nice even number like that. Many times they will not. So I might just give you points like negative 7, 2, and 5, 8. So to set this up, distance is I call this point 1 and point 2. What is x2 going to be? 5 minus, what's x1? Negative 7. Good. That'll be squared. Plus, what's y2? 8 minus y1? 2. Good. And that's going to be squared. Now this time, I just as well go ahead and punch this in the calculator all at once. Second square root. Parentheses here, 5 minus negative 7. Close my parentheses. Squared. Plus, open my parentheses. 8 minus 2, close my parentheses, and squared. And I should get 13.4164. So it is 13.4164 units is the distance between those 2 points. Well, why is this useful on a job site? Well, sometimes job sites are laid out on a grid system. Just like our graph, you might have a 0, 0 point here. If you get into the surveying side, everything is definitely laid out on a grid system then, and you have to be able to identify stuff. But if I have an item that's located here at 1, 7, now that might be 1 foot over, 7 feet over. Typically it'll be either yards or rods. And I might have something else down here that's located at 9, 2, and I want to know the distance between them. As long as I know that these grids have uniform sizes, that there's a set dimension for each box on that grid, I can now find that distance. If I call this point 1 and this point 2, what is x2 going to be? 9 minus x1 will be 1, so 9 minus 1 squared, plus, next parentheses, what's y2? 2, very good, from second point, y coordinate, minus, what's y1? The 7. Perfect. Well, but still, remember, the formula is minus. It's x2 minus x1. So even though both x1 and x2 are positive, it's still 9 minus 1. And the same here, y2 minus y1. Even though they're both positive, it's still minus the 7. So now we just go ahead and we'll punch that in. Second square root, parentheses, 9 minus 1, close parentheses, x squared, plus parentheses, 2 minus 7, close parentheses, x squared. We get 9.434, it looks like. 9.4340. And whatever unit is our grid spacing is the distance, the units that go on that distance. We might also be looking at doing a support or guy wire. If we're looking at a telephone pole, and we need that wire to go, be careful. We need that wire to go 30 feet up that pole. And we're going to anchor it down here to another pole. This pole is 18 feet away and 4 feet tall. What we end up with here, running that cable down through, we end up with here, this is at the point 0, comma 30. And this down here is at the point 18, comma 4. So we can find the distance between them. If I call this point 1 and point 2, what's x2 going to be? 18 minus what's x1? 0. So that's going to be squared. Plus what's y2? 4 minus what's y1? 30. That's going to be squared. So let's walk through this one. What is 18 minus 0? 18. Very good. So that's 18 positive 18 squared. Plus, what is 4 minus 30?
Negative 26.
Negative 26. That's going to be negative 26 squared. So now our next step, we're going to have to square them. 18 squared is 324. Good. Negative 26 squared. Now again, be careful that you deal with the negative. Put the negative in parentheses. 676. Perfect. We add those together. 324 plus 676 is going to be 1,000. The square root of 1,000 is going to be 31.62 feet. Very good. And now again, to tie this together, we do that square root of 1,000 with 31.62. If we want to keep going, 6227766. If we need to convert that now to measure that out into feet, inches, and eighths, actually let's do this. We're going to do feet, inches, and we're going to do sixteenths. So that is going to be 31 whole feet. So 31 feet. I'm going to calculate, I'm going to subtract the 31. What do I do now with the 0.62277? Times 12 to make it inches. Perfect. So I got 7.47. So that's 7 whole inches. What do I have to do next? Careful. I have to subtract the 7. There we go, to get rid of the whole inches. Now I have to multiply by the 16. So I get 7.57 sixteenths. That's between 7 and 8 sixteenths. Which is it closer to? 8 sixteenths, which will reduce to 1/2 inch. So to the nearest 16th of an inch, that cable there needs to be 31 feet, 7.5 inches. Okay, I've got a, I can't have her work on the quiz with the test with me.
If I do it in different colors?
Yeah, I can't do that now. Not till after it's been graded. Sorry. But if you know what's on there and you want to discuss it with her, okay. If you want to look back through my math lab stuff, you can try that and then work on it more later.
Okay.
Sure. Okay. So that's what we can use that for on a job site. So let's take a look. Then our next thing we want to look at, sorry for the interruptions, guys. We're going to look at midpoint formula. There are going to be a lot of applications where finding the middle of something is important for us. Finding the center. For example, when we talked about trapezoids, there's something called the median of a trapezoid. The median of the trapezoid goes from the two sides that are not parallel, from the center of one of them to the center of the other. And finding the location of that median, the end point of that median, is at the center or the midpoint of this side. And the same here. It's going to be at the midpoint of that side. So finding those midpoints is a very useful tool to do. So if we look back at a graph again, let's say I have a point on here at 1, 7, and another point at 9, 3. And it is connected with a line segment like that. If I want to find the middle of it here in the very center, well, I'm going to look back. We've used that triangle before, the rise and the run. Let's look at that again. So we've got a rise there and the run across there. If I were to project that midpoint over this way, it would hit at the center of that rise. And the same here, if I projected it down, it's going to hit at the center of that run. So the endpoints of this run are just the x coordinates. I have 1 here and 9 here. So this coordinate of that midpoint is in the middle between 1 and 9. How do we find a number in the middle of between two other numbers? We find the average. Boy, I can't write today. Let's try that again. We'll find the average. There we go. To find the average, we just add the two numbers together and we divide by 2. So 1 plus 9 divided by 2. Now we do have to be careful when we're doing this on the calculator. We have to do 1 plus 9, and then we have to hit equals before we divide by 2, which is going to give us 5. Then that's for the x-coordinate. For the y-coordinate, we do the same thing. This here would be at a y of 3. This here is at a y of 7. To find that point in the middle of them, we average those together. So 3 plus 7 divided by 2. And that's also 5. So what that's telling us is the x-coordinate of that midpoint is 5, and the y-coordinate of that midpoint is 5. So the midpoint, or the middle of that segment, is at 5, 5. So what we did there to find that midpoint, the coordinate of the midpoint, we found the x-coordinate and the y-coordinate separately. To find the x-coordinate, we took our two x-coordinates, 1 and 9, we added them together, we divided by 2. That gave us 5. To find the y-coordinate, I'm going to change color here. To find the y-coordinate, we took the two y-coordinates, 7 and 3, we added them together and we divided by 2. That gave us the 5 for the y-coordinate, giving us that point 5, 5. The formal way of writing that, if we have points x1 and y1 and x2 and y2, the midpoint is found by averaging the x-coordinates to get the x-coordinate, averaging the y-coordinates to get the y-coordinate. So let's take a look at finding some midpoints here. If I give you the 2 points, -4 and 3, and 6 and 11. To find the midpoint, let's find the x-coordinate of the midpoint. What am I going to do? We got it. 6 plus -4 or -4 plus 6, either way. And divide by 2. So -4 plus 6 is 2. Divided by 2 is going to give us 1. So 1 is the x-coordinate of the midpoint. For y, what are we going to do?
Minus 3, or 3 minus 11.
Not minus, but plus. We're going to add them. Very good. 3 plus 11 divided by 2. This is the one formula where we don't subtract the coordinates. We actually add them together. So 3 plus 11 is 14. Divided by 2 gives us 7 for the y coordinate. So the midpoint, or the point that's exactly between those 2 points, is the point 1, 7. Let's do one more, and it should be about time for a break. So let's do, I'm actually right today, 5, negative 2, and negative 9, 10. So for my x-coordinate, where do I start? Negative 9 plus 5. Good. And then divide by 2. So negative 9 plus 5 is negative 4. Divided by 2 is negative 2. So our x-coordinate is negative 2. For the y-coordinate, what are we going to do?
10 minus negative 2.
Not minus, but plus. Yep. 10 plus negative 2, and then divide by 2. What's 10 plus negative 2? Positive 8. Divided by 2 will give us 4. Very good. So the midpoint, exactly between those 2 points, is negative 2, 4. Okay, it's about time for a break, so go ahead and take 3 minutes, and we'll come back here in a few. Okay, there we are. Let's go ahead now, and we'll take a look then at some notation that goes along with this. The 2 endpoints are going to be labeled points A and B. So point A is 3, negative 8, and point B is 11, 2. The midpoint is going to be labeled point M. Very creative, right? For midpoint M. So now then, to find that midpoint, M is going to be found by averaging those x coordinates together. 11 plus 3 over 2. And the y coordinates together. So 2 plus negative 8 over 2. So 11 plus 3 is 14. Divided by 2 is 7. 2 plus negative 8 is negative 6. Divided by 2 is negative 3. So there's our midpoint, and that's how it's found. But what if instead of giving you points A and B, what if I give you point A as negative 2, 11, and the midpoint as 3, 8, and I tell you that I want you to find point B. Well, I do this exactly the same way as what I did up here. Up here, I average together the x coordinates, the 11 and the 3, to get 7. I average together the y coordinates, the 2 and the negative 8, to get negative 3. I'm going to do the exact same thing down here, only I'm going to have to use some algebra to solve. So what I'm going to do is I'm going to call this missing x coordinate in point B is just x. The missing y coordinate in point B is just going to be y. Now my midpoint would be found by averaging together the x coordinates. So x plus -2 over 2. And then averaging together the y coordinates. So y plus 11 over 2. So now here we know that the x coordinate of that midpoint is 3. So we know that x plus -2 over 2 equals 3. So we can now solve for that x coordinate. What would be the first thing we'd have to do to solve this for x? Multiply by 2 to get rid of that 2. So this is going to be 6 over here. So we've got x plus a -2 equals 6. Then what? That's a -2, so we're going to add 2 to get rid of it. So x equals 8. So that's telling me that this x coordinate here is 8. To find the y coordinate, we look at the y coordinate of the midpoint. We know that y plus 11 over 2 is how we find it, but we know it equals 8. So y plus 11 over 2 equals 8. What's going to be our first step in solving that? Multiplying by 2 again, right? Make that 2 go away. 8 times 2 is 16. So y plus 11 equals 16. Then what?
Subtract 11.
Perfect. Subtract the 11. So y equals 5. So again, coming up here, we know that this y coordinate is 5. So that missing endpoint is 8, 5. So if I give you that point A is 7, -1, looking to find point B, and I know my midpoint is 4, 5. So I'm going to call these x and y again. I'm going to separate this out and do the x coordinate first. If I were finding the x coordinate, what would I do with these points to find the x coordinate of the midpoint? Careful. No, we stick with these two. X plus 7 divided by 2, and then that has to equal the 4 from the midpoint. So let's solve that. What are we going to do first? Multiply by 2. So x plus 7 equals 8. And then subtract the 7. So x equals 1. For our y coordinate, we're going to set up a similar formula. What are we going to start with?
Y plus -1.
Okay.
Divide by 2.
Divide by 2
Equals 5.
equals 5. Perfectly. Y plus -1 divided by 2, we average them together, has to give us the 5. So solving this, what's our first step going to be? Multiply by 2. So y plus a -1 equals 10. And then add 1. So y equals 11. So that missing endpoint is 1, 11. So if I'm missing point A here instead of point B, so I tell you that point B is 2, 7, and the midpoint is at negative 3, 2. So once again, I'm going to call my missing coordinates here x and y. To find the x coordinate, what am I going to do? Perfect. The x coordinates, the x and the 2 are averaged together, so x plus 2 divided by 2 has to equal the x coordinate of our midpoint, the negative 3. So what do I do next? Multiply by 2. X plus 2 equals negative 6. And then we subtract 2. So x equals negative 8. For y, what do we do? Y plus 7 divided by 2 equals 2. Good, from here. Then what? Times 2, good. Makes that 2 go away. Y plus 7 equals 4. Subtract 7, good. So y equals 4 minus 7 is negative 3, good. So the other end point is negative 8, comma, negative 3. Okay. We can do similar things like this with that length formula. So if I have point A is 1, 7, and point B is 7, negative 1, I can find the distance between them, or the length of that segment. Well, it's going to be the square root of 7 minus 1 squared, and negative 1 minus 7, good, squared. Seven minus 1 is 6. That's going to be 6 squared. Negative 1 minus 7 is negative 8, so that'll be squared. Careful. 6 squared is 36. Good. And negative 8 squared? Positive 64. Those add up to be 100. And the square root of 100 is 10, right? Perfect. So distance is 10. Well, what if we're missing one of these points? Now, we can only be missing one coordinate of one of those points is the key. So let's say I tell you that point A is x and 7. Point B is 8 and negative 5. And the distance between those points is 13 units. So we got to remember, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So what goes in for the distance? 13. X2 is going to be 8 minus x1 is going to be x plus, over here, what's y2 going to be? -5 and -7. Very good. So, there's nothing I can do with this one so far. That's just going to be 8 minus x squared. But I can do what's -5 minus 7? -12. There's still nothing I can do here, so this first part's going to stay the same. 8 minus x squared. What is -12 squared? 144. Good. Now to solve this, I'm going to get rid of this square root symbol here. What's the opposite of a square root? Squaring it. So I'm going to square the 13, and I'm going to square here to get rid of the square root. So 13 squared is 169. Good. Over here, what I have is 8 minus x squared plus 144. Now to solve this, to continue to solve this, I should say, I'm going to have to subtract the 144. So that's gone. 169 minus 144 is 25. Now I have that 8 minus x squared, and the opposite of squaring is the square root. What's the square root of 25? It is 5, or -5. So we got to be careful of that. Over here, we square rooted that. This is just 8 minus x now. What we have is we have two equations that we have to deal with. We're going to have 5 equals 8 minus x. Perfect. Or -5 equals 8 minus x. And either way, I'm going to make this a -1 times x, so it's easier to solve. Here I'm going to have to subtract the 8. Gives me -3 equals -1 times x. Then what? I divide by -1. Gives me that 3 equals x. Or, on the other side over here, I would subtract 8. Perfect. What's -5 minus 8? Careful. -13. Good. And now I divide by -1. 13 equals x. So here, either x is 3 or 13. Now that makes sense. If I'm looking at a graph here, I had the point 8, -5. I'm going to put that one on there first. So 8, -5 is going to be right here. That's that first point. That's point B. And then for A, it is x and 7. So all I know is that somewhere on this line here is point A. Well, to get a point that is, 13 units away, there could be one over here where x is 3. So that would be at 3, 7. Or there could be one over here where x is 13. That'll be at 13, 7. So the other end point can be either one of those. Now, because in the next portion of the course, graphing is going to be vitally important to us to start out with, I want to take a little bit of a review of our slope-intercept graphing. Exactly. Y equals mx plus b. Slope times x plus the y-intercept.
You can also say plus or minus b.
Plus or minus b, exactly, if b is negative. Exactly right. So let's do that. Y equals 3/4 x plus 5. Where is this going to start on my graph?
It's going to say positive.
Careful.
No, positive.
Positive 5. 1, 2, 3, 4, 5. So that's my starting point. Let's have our seat back there, guys. So then from there we do what? Up 3 over 4. Good. Up 3 over 4. And my line goes through those 2 points. Now, we had said before that we could go multiple times with that slope if we wanted to. Now, that one kind of runs out of room, so I'm going to do another one. Y equals negative 1/2 x plus 1. Where is this one going to start out at? Positive 1. Good. And from there it goes... Yeah, it's negative 1/2, so it goes down 1 over 2. Now here, since those points are so close together, if I want to accurately draw that line in, I'm going to repeat it. I'm going to go down 1 over 2 again. Down 1 over 2. In fact, I can go the other way. I can go backwards. Back 2, up 1. Back 2, up 1. And I can make those points so I can get a pretty accurate sketch of my line across the graph. The reason we're doing that is what in our next section, we talk about solving systems of equations. We're going to need that line to be really close to being right on because we're going to look at where those lines cross each other. Now, those lines may not be perfectly given in that form. We might have an equation that looks like this. Let's go 2y equals 3x minus 4. What are we going to do with this? Well, we need to get y by itself. And right now, y is being multiplied by 2. So we're going to get rid of it by dividing by 2. Good, the opposite of multiplication. Now, when we divide, every piece, every digit of the equation has to be divided by that number. So dividing by 2 here cancels out that 2 and leaves us with a y. But on the other side, we have to divide both of those digits by 2. So 3x divided by 2, we just make the 3 divided by 2 into a fraction. So it's 3/2 x. Negative 4 divided by 2 is negative 2. So when we graph this, we start at negative 2. Good. And from there we go up 3 over 2. Good. And I'm going to do it again. Up 3 over 2. So now, let's take a look at y plus 5 equals 3/4 x plus 6. Now here, once again, y is not by itself. What do we have to do to get y by itself? Subtract the 5. Now when we add or subtract, we only have to do it to one digit on each side of the equation. So we subtracted that 5, leaves us with y. On the other side, I'm just going to subtract 5 from the 6. So the 3/4 x won't change. 6 minus 5 is a positive 1. So now to graph that, I'm going to start at 1, and then I'm going to go over 4 up 3, or up 3 over 4. I could go again if I wanted to. And now here, because I plotted this out closely, I can find the point where those two lines cross is right there. That's 1, 2, 3, 4. 1, 2, 3, 4. They cross at the point 4, 4. In our next section of the course, that's a very important skill to have, is finding where two lines cross on the graph. Well, it can be a little bit more complex than that. We might have 3y plus 1 equals 2x minus 5. So we're going to have to do two things to solve this before we can graph it. We have to get y by itself. Y has been multiplied by 3, and then 1 has been added to it. What's going to be the first piece we remove? Careful. We're going to subtract the 1 first. Remember, reverse order of operations. If we were building it, we would multiply first and then add. But when we take it apart, we go backwards. So we're going to subtract first. So that's gone. So we have 3y. The 2x isn't going to change. Negative 5 minus 1 is negative 6. Now we're going to go ahead and divide by 3. So that 3 is gone. Each digit has to divide by 3. So 2x divided by 3 is 2/3 x. And negative 6 divided by 3? Negative 2. So we start out at negative 2, and from there we go up 2 over 3. Wonderful. Or over 3 up 2, either way. Yep. The final stage might look like this. 2x minus 5. Oops, I don't know why I wrote 2x minus 5y equals 10. So I need to get y by itself. I have to get rid of everything else. Y has been multiplied by a negative 5, and 2x has been added to it. So to take it apart, I've got to reverse that process. So I'm going to subtract the 2x. Perfect. Negative 5y equals 10 minus the 2x. Then I need to, well, careful, the negative 5 is attached to the y how? It's perfect. It's multiplied, so we're going to divide by it. Good. So dividing by negative 5 gives us y there. Dividing by negative 5 here. 10 divided by negative 5 is negative 2. Negative 2x divided by negative 5. Perfect. 2/5 x. Negative divided by negative is a positive. So we start our graph at negative 2, and from there we go over 5 up 2, or up to over 5. Okay, that's it for our new material for today. I'll give you the last 13 or 14 minutes here to work. Is Mr. Berghammer in the room there with you? No, he's gone? Okay, did they give you a worksheet for today? No. No, okay, well that puts a wrench in it a little bit. What I'm going to do until Mr. Berghammer comes in, or comes back tomorrow, I'm guessing, I am going to put the worksheet up on the board here for you. If I can get to it, there's my H drive here. Here we go. I'm going to blow this up so you guys can see it. So that first section is finding the slope from those points. The second section deals with the midpoints. If you get done with those sections before class is over, let me know and I'll scroll it down further for you.